Hello everyone. In this particular video, I'll be talking about complements of set. However, a detailed discussion I have already given about complements of sets when in my introductory videos. But I'll be refreshing the concept a bit, and we'll be definitely taking up numerical examples and talking about complements of set. So first, exactly, we need to see that how a complement of set can be represented as. So if A is a set, then complement of A can be represented by something called A complement. You can write it this way. So many places you will also see it written like A dash. That's how the complement of set is represented. And how do you define actually complement of set? So complement of set is generally defined as X such that X does not belong to A. And means all the elements which are not part of A becomes the part of complement of A. In detail, I can draw a Venn Euler diagram for this entire thing. So if I start drawing a Venn Euler diagram, then you can simply see that this is the universal set. You all understand the concept of universal set. You can see again the introductory videos. And this is set A. Then this shaded portion represents A complement. That means this shaded portion is everything else apart from A that becomes the part of A complement. So this is actually A complement which it is representing. So we're going to build the same particular concept and we'll try to understand how the different problems using complement of a set can be solved. So let's see the first example. I have got a universal set here which contains element 1, 2, 3, 5, 6, 7, 8, 9. And there is a set A called 1, 2, 3, 4, and B is 2, 4, 6, 8, and there is a set C 3, 4, 5, 6. So if you see A, B, and C, all are the subsets of universal set. And the first problem, which exactly is there, I want to find out complement of A. So as per the definition, all the elements which are, not the part of A becomes the part of A complement from the universal set. So if you see 1, 2, 3, 4 are part of A. So 1, 2, 3, 4 are part of A. And remaining elements, that means which are not part of A, becomes the part of A complement. That means the A complement here would be 5, 6, 7, 8, and 9. So that's A complement. If you want to see the Venn Euler diagram of it, again I can sketch a Venn Euler diagram which can be easily understood. So this is A. If I see it and it contains 1, 2, 3, and 4. So this is A. And then 5, 6, 7, 8, and 9 are here, which means, of course, some of them are going to be a part of B and C. But specifically, if I'm talking about A, then this shaded portion becomes complement of A. This is entirely a universal set, and this shaded portion becomes a complement. So generally, in notation, you can write it here what you're representing. That means a complement can be written somewhere here. So that's a complement for you. Let's think about another particular example where exactly I can find out, let's say, uh, complement of B. So now I'm going to collect the elements from universal set which are not a part of B. So B has 2, 4, 6, 8, and in the universal set I'm going to see that 1 is not a part of B. 2, as far as concerned, is a part of B, so I'm not going to take it. 3 is not a part of B, so I'm going to write it 3. Then 5, once again, if you see 3 is not a part, so I've written it. 4, again 4 is there in B, so I'm not going to write it. 5 is not there in the B, so it will become the part of my complement. And same way, you can see 7 and 9 are also not a part of B, and that becomes a part of B complement. Same way, you can diagram this B complement by using Venn Euler diagrams. And if this is set B, let's say here somewhere, and set B is 2, 4, 6, 8, then rest of the elements, let's say 1, 3, 5, 7, and 9, they become the part of B complement. So that is B complement. This is universal set for you. This is set B, and this is exactly B complement. So that is how the we can conceptualize the complement of a set. Let's see some little different problems. So one problem I have right now with me is, what if, what if, you know, I am writing it that you have been given something like that you have to find, let's say, A union B complement, what it is going to be. So I just need to find out whatever the elements are which are not a part of A union B. So diagrammatically, if I want to see it, then simply it is A and it is B, and this shaded portion is actually the union. So this is A, this is B, this shaded portion is actually the union, and this remaining portion becomes the part of, you know, the dotted portion becomes the part of A complement B. That means A union B complement, sorry. So for that, first I'll find out A union B, and whatever members are not a part of A union B, that will become the part of A union B complement. Let me find A union B. By definition of A union B, I hope it can be easily understood that the members which are a part of A and B and non-repetitively. So what are the members of A? 1, okay, 2, 3, 4. I'll see in B, 2 already covered, 4 already covered, 6 is left, and I'm left with 8 also. So this is A union B. Now I'm going to compare this A union B with the universal set to find the complement of it. So what will be the complement of A union B? Now I can see what are not the members of A union B. So 1 is a member of A union B, so it is not going to come in the complement. 2 is a member of A union B, so it is not going to come in the complement. 3 is a member of A union B, it's not going to come in the complement. 4 is a member, 6 is a member, 7 is a member, 8 is a member. So what is left? So not the 7, I'm sorry. 6 is a member, 8 is a member. So what are the elements left? 5, 7, and 9. So it is going to be 5, 7, and 9. So that is A union B complement. Let's see one more very interesting example, and this particular example is going to let us understand that how different problems related to, you know, complement can be solved. So I need to calculate something minus B minus C complement. So again, what I have to do is, first of all, I need to find out B minus C, and then I'll find its complement. So let's find it out. And what I'm going to do is, because I'll find first of all B minus C. So B minus C is members of B but not of C. So what are the members of B and not of C? If you see 2 is a member of B but not of C, 2 becomes a part of it. And if you see 4 is a member of C also, it is not going to come in the difference. 6 is also a member here, so it is not going to come in the difference. The other member is 8. So that's B minus C for you. You can see the difference of set in the previous video. And now I want to find the complement of it. That means the elements which are not a part of B minus C but a part of universal set. So essentially you can see that leaving only 2 and 8, the rest of the elements are going to be part of B minus C complement. So it is going to be 1, 3, 4, and then 5, then 6, 7, and 9. So that is B minus C complement for you. That is you know how some more problems of complement can be solved. Let me go to one another example, and there is a little result which we can prove by using the complement of a set, and this is a very useful result. In fact, I should say. So I've been again given with a universal set, a set A and a set B, and I've been asked that verify that A union B complement is equal to A complement intersection B complement, and the second part is A intersection B complement is equal to A complement union B complement. So let's verify these results one by one. So first what I'm going to do is I'm going to verify the result on my left. Let's do that. So I'll find the left hand side first of all. This is the left hand side. That means A union B of complement of A union B rather. For that, first I'll collect A union B. And what is going to be A union B here? A union B is going to be simply 2, 4, 6, 8. 2 I have already covered, 3 definitely, and then 5, and then 7. So that's A union B for you. Now if you see A union B complement, then 2, I'll compare it once again with the universal set here. The members which are not in A union B. So what it is going to be, the elements which are left are 1 and 9. You can see that 2, 4, 6, 8, 3, 5, 7 are already covered in A union B. So complement is going to be 1 and 9. This is one first equation. I can write it. I'll check the right hand side in fact. And the right hand side is A complement intersection B complement. So let's write A complement first of all. So A complement is the members which are not a part of A. So the A complement here is going to be 1, 3, 5, 7, and 9. You can think about it, see it. And then intersection, I've written A complement first of all. Then intersection of B complement, which is 1, 4, 6, 8, and 9. That means the members which are not a part of B, and it is the B complement which I've written here. And if I find the common elements in between them, then it is 1 and 9. Once again, 1 is here, 9 is here. So that's the intersection. And this simply shows that your this, if you take it to equation number 2, so from first and 2, you can simply see that LHS left hand side is equal to right hand side, and hence I can simply verify this particular result. Let us see result number 2 once again. So first of all, I need to see the left hand side here, which is A intersection B complement. So I need to first of all find what is A intersection B. So if you see A intersection B here, 2 is the only common element, right? So it is going to be 2, a singleton set. And what is complement of A intersection B? That is simply everything which is not 2. So that is going to be 1, 3, 4, 5, 6, 7, 5, and 9. So that is the LHS. Now I'm going to calculate the right hand side, which is exactly A complement union B complement. So the A complement simply can be written as 13579, which we have already done here. You can see we have done here, so I'm using this result simply. Then union of B complement, which is 1, 4, 6, 8, 9. Again, you can see that I have written it already here. And if I try to find their union, that is going to be 1, 3, 4, 5, 6, 7, 5. Okay, I think I missed. Okay, this one is 8. This one is 8. 8 and 9. So if you see, you can verify this is equal to this. That means left hand side is equal to right hand side. Thank you very much. Let's meet in the next video.